When we talk about equations, what we're really talking about is how one quantity relates to another. So remember that when we look at y equals, say, 2x plus 4, x means something in the real world and y means something in the real world. They represent, that's what variables are. They're the unknown that we use to figure out what we don't know. We're going to look at a specific type of relationship here, and this is something we've talked about specifically in Chapter 7 when we talked about things being proportionally related. Well, things that are proportionally related, there's another name for that. It's called direct variation. So two things that relate proportionally, meaning if there's the ratio of those two things stays equal, so equal ratios is a proportion, then they are said to have, they vary directly, or think of the word variation in variable. So those variables follow that same pattern. Well, here's the official definition. Two variable quantities are related proportionally by a constant positive ratio. This ratio is called the constant of proportionality. And here's the formulas that we'll need here. Y equals kx. If it is an equation with direct variation, it'll always have this form. So like y equals 3x, yeah, that's proportionally related. Or even y equals x over 3, because that's the same thing as y equals 1/3 x. K, or the constant of proportionality there, if it's x over 3, is 1/3. If I have, though, y equals 3x minus 4, that is not a direct variation because we have this minus 4. Remember when we talked about in Chapter 7 and Chapter 5, for there to be proportionally related, they have to go through 0, 0. They have to be a straight line. If you add something to the equation, it throws off the proportionality. To test for this, we could either, so I've got two tables here. One has shoe size, U.S. size versus European size. If you ever look at the size of your shoes, you notice the European size is different. So the question is, are these sizes, do they vary directly? Well, you could look at the graph, and you'll notice from the graph that this doesn't form a straight line. Okay? So it does not vary directly because it's not a straight line. It might not go through 0, 0. We've got some breaks here, so we really don't know where this is going to hit. I would assume it's going to be 0, 0. So if you wear a size 0 US, you wear a size 0 European size. It's kind of a weird thing to think about. But the other thing we can do to test this is to look at the ratio. So let's say I take 39 to 7. So if you wear a size 39 European, that's the same thing as wearing size 7 in US. Well, if I wear a size 45, then I wear a size 11. So the question is, are those proportionally related? Well, check the cross products. 45 times 7 is 315. And 39 times 11, and we're seeing if this is equal, 39 times 11 is 429. So right away, no, the sizes are not proportionally related because not all the ratios of the sizes are equal. Look at the other example then. This is the distance that sound travels at 20 degrees Celsius. 20 degrees Celsius just means that's the condition that we have to be under. So in 0 seconds, sound travels 0 meters. In 1 second, it travels 350 meters, and so on and so forth. You'll notice this is direct variation because it goes through 0, 0, and it's a straight line. Well, what if I didn't want to graph it? Well, then I would have to look at all of these ratios. So look at 0, 0 we wouldn't really look at because you can't really divide by 0. But do all of them equal 350 to 1? Well, if I have 700 over 2, if I divide that by 2, I get 350 to 1. If I do 1050 to 3, 1,050 seconds, or I'm sorry, 3 seconds, 1,050 meters. If I divide top and bottom by 3, again, I get 350 over 1. And spoiler alert, 1,400 over 4 divided by 4 is 350 over 1 again. So all the ratios are the same. So the constant of proportionality here would be 350, right? So my equation here would be y, distance depends on time. That means distance is y, time is x, okay? So y equals 350 times x. For each second I go, or for each second of time, I go another 350 feet. So that's how we do the equation like that. It's pretty easy to write the equation once we know it varies. It varies directly. There's direct variation, or it's proportionally related. So here we're going to look at how do we write these, how do we find these equations of these direct variations. So if there is direct variation, okay, so that's one of the givens here that you have to pay attention to. Given that y varies directly with x, well then they're all going to follow this y equals the constant of proportionality times x. To do this, though, I need to know what the constant of proportionality is. So if you notice, if I solve for k, I would have to divide both sides by x. So k is going to equal y divided by x. So that's all I got to do to find k. So for number 1, for instance, k, y is 52, x is 4. Get a calculator on this. 52 divided by 4 is 13. So k is 13. So my equation is y equals 13x. Done. Second one. K equals y divided by x. Well, 10/15ths, it's going to come out to a decimal. Rather than get a decimal, let's stay exact. I'll just simplify this as a fraction. So k equals 2/3. So y equals 2/3 x. Done. And then the last one, y is 5, x is 2. So k equals 5 over 2. Already simplified. I mean, you could go 2.5 because that's exact, but why not just leave it as a fraction? Make it easier on yourself, right? So 5 halves x. There you have it. So it's pretty easy to find these equations. It's a little bit more difficult to figure out the whether they do have direct variation, but that's just looking at the ratios. So pretty simple concept, but I wanted to make sure you understood how this relates to things being proportionally related. So let me know if you have any questions on this, and go ahead and try some of those problems.